Okay, we're going to do a little video session here on classifying quadrilaterals. So hopefully you already watched the video on classifying triangles. So this is going to be some similar stuff, but a little bit extra here, maybe a little bit more work involved with quadrilaterals than triangles. But so just a reminder, when we say classify, what that means, right? So in kind of general terms, when we classify, we're going to give the categorization, or really we're going to give the most specific name we can. Most specific name possible for that quadrilateral, right? And quadrilateral, quad, hopefully we know quad means four, right? So quadrilateral are four-sided figures. So we know there's a lot of four-sided figures we've seen. How do we actually give or investigate those to be able to give the most specific name possible? So to classify a quadrilateral on the coordinate plane, which is where, on the graph where we're going to be operating, we're going to have to examine side lengths and slopes of the sides, and we're going to compare them to each other. So we did the side length comparison with the triangles, right? If all three were the same, they were equilateral. Two were the same as isosceles. If none were the same, it was scalene. We're going to do the similar thing here. We're going to look to see if the side lengths are the same, but we're also going to have to look at the slopes and use that to dig a little bit deeper here. So we can work directly off the graph, which is what we're going to primarily do, right? We're going to work directly off the graph using the points and the sides on the graph to form our triangles and be able to calculate the slope directly off the graph and then use the Pythagorean theorem. If you're someone that likes formulas, maybe you're already ready for this. Eventually in Math 2, you're going to have to use these formulas and not necessarily work just directly off the graph, but we have our slope formula and we have our distance formula. So if I give you two coordinates or four coordinates, you can find the length, the distance between two of them using the distance formula. So you can find the side lengths with coordinates and equations. Same with the slope. So you never have to graph the points, you can use the equations. We're not going to probably focus on that too much right now. So when we classify our quadrilaterals, the first thing we're going to do is, and we're going to really only focus in on one area, but I'm going to give you a big overview and then zero in on what we're going to kind of focus on for right now. So there are going to be three kind of main classifications within quadrilaterals, or at least beginning classifications: parallelograms, trapezoids, and kites. And you can see here what the definitions of those are. So a parallelogram, I think, most of us could probably think of what a parallelogram looks like. It's a quadrilateral, so it has four sides with two sets of parallel sides. So that means, I don't like to say top and bottom because I could orient this thing differently, but let's just say it has one set of opposite sides there, top and bottom, and then a second pair like this, right? And parallel, we can show that lines or segments are parallel by putting an arrow on it. So if I have an arrow on it like that, that means that those two are parallel. And I could show that these are parallel by putting two arrows on it, because it's different than the one, right? So it's just like when we marked side lengths for congruence, you could use one hash mark or two, right? The ones were all the same, the twos were all the same. Same here. So that's a parallelogram generally, right? A trapezoid is a quadrilateral, so four sides with one set of parallel sides. So it's going to have something like this, where there's one set of parallel sides, but the others are not parallel, right? They might look like that. And a kite is a quadrilateral with two sets of adjacent congruent sides, but no congruent, whoops, I didn't, opposite sides, so I cut that off there. But a kite's going to look like a kite, imagine that. So it's going to look kind of like this, right? So it means that these two are the same, congruent, and these are the congruent. Right, so the consecutive, right, in a row, so there's 2 in a row and there's 2 in a row, but the ones that are opposite are not the same length, so that's a kite. So in kind of a traditional classroom setting, we'd spend a whole lot of time on all of these, doing lots of investigation. We're going to kind of focus primarily on parallelogram and working down, so we're going to kind of start here and we're going to work our way down. So we're not going to see too many trapezoids today. So parallelograms, quadrilaterals with 2 sets of parallel sides. So as long as, again, I don't like to say top and bottom, but as long as the top and bottom are parallel with each other, and the left and right there are parallel with each other, that's a parallelogram. Now I could get even more specific, right? A parallelogram could be a rhombus, right? A rhombus is a type of parallelogram. That's a parallelogram that has 4 congruent sides. So you can see the parallelogram, computer's getting a little bit slow here, but the parallelogram I drew here in blue, right, the top and bottom are congruent, but the left and right are congruent, but there's a long side and a short side, right? A rhombus means all are the same. So let's actually do it a different color. So that means not only are we having 2 sets of parallel sides, but actually all 4 of these are the same length also. And a rectangle is a parallelogram with 4 right angles. So not only are, again, I hate to say top and bottom because we could flip it around, but just since we're not here to illustrate in person, the top and bottom, right? So here the top and bottom are parallel and these shorter sides are parallel, but they're also 90 degrees. So a rectangle, I think we know what a rectangle is generally. And what we're going to focus on with a lot of our problems that we're going to see coming up here is going to be investigating to see if quadrilaterals are rectangles. So we're going to have to look and see, are there 2 sets of parallel opposite sides? And are the angles all 90 degrees? So we need to investigate that. So how do I know if something is a right angle? I know there's a right angle if the sides have slopes that are opposite reciprocals. So that's going to be really important, right? We're going to look at the length of each side, and then we're going to look and see what the slopes of each side are, and if they're opposite reciprocals, then that means that that's a 90-degree angle, so we have to do it 4 times, a lot of work on these, actually. Okay. Our most specific classification actually is a square, and you can see it goes from rhombus, right, and rectangle, both lead down to square. A square is a parallelogram, it's a rhombus. A square is a parallelogram that's both a rhombus and a rectangle. So not only does it have 2 sets of opposite parallel sides, but all the sides are the same length, they're congruent, and there's 4 right angles. So you guys know what a square is, we see it every day, right? There's 4 sides, they're all the same length, and they all have 90-degree angles, right? But a square is a type of rectangle. Right? We typically think of a rectangle being longer in one direction, but technically this down here on the bottom, this square, that is a rectangle, but it's not the most precise name. That's why when we say classify, we're trying to give the most precise name. Okay, so that's kind of our background. We're going to go ahead and do a few problems. Again, these are not fast. These are pretty labor-intensive problems because we need to find the slope and the length of all 4 sides. So we're going to go ahead and, actually I'm going to move my graph over a little bit so I'm certain I have enough room. and we're going to label these points here. So we have determine if the quadrilateral with these vertices is a rectangle. So we're going to plot the points. So negative 3, 0. That's A. Negative 1, 2 is B. 3, negative 3 is C. And 1, negative 5 is D. Okay, so we plot and label, and now, I mean, you may be able to look at it and tell if it's a square or not, but we need to prove it, right? We have to show our work, and so this is important stuff here. So determine if it's a rectangle. We know that the first thing we need to do is find the length of all sides. So we're going to go ahead and do that. So AB, let's do side AB. So that goes up 2 and over 2. So for AB, I know 2 squared plus 2 squared equals C squared, right? C is the one I don't know. So 2 squared is 4. So 8 equals C squared. So C, if I take the square root of this, and I do the same thing there, C is the square root of 8. So that's the length of AB. Now I'm going to do this 4 times. The second thing I'm going to have to do is find the slope of all sides. So I'm just going to do that at the same time because I think it'll be a little bit easier. So AB, the slope of AB, I can see it goes up 2 over 2, right? The same two numbers that go into Pythagorean theorem are going to go into slope. Make sure for the slope you keep the sign is really going to matter a lot. So it goes up 2, right 2. So my slope for AB, right, is 2 over 2. And I could reduce that, but I'm just going to leave it for right now because I think it's a little bit easier to see a fraction. Because when we talk about reciprocals, we want to see when we flip them what happens. So now, I'm going to go like that. Let's do it for our second side, which would be BC. So let's do that in red, I guess. So BC is this side right here. So I'm going to make a triangle. And this side on the top is 1, 2, 3, 4. And this side is 1, 2, 3, 4, 5. So 4 squared plus 5 squared equals C squared. 4 squared is 16, 5 squared is 25. Add them together, I get 25, 35, 41 is C squared. And C is the square root of 41. Now to find the slope of that side, remember we always read ours from left to right, so I'm always going from left to right. So if I go from left to right, it's going down. So this is where I need to think of my sign, right? So it's going rise over run, or change in y over change in x. It's going down 5. Remember, I always go up or down first, and then to the right, it's going 4. So my slope is negative 5 over 4. So I already have enough information I could answer this question, but I'm going to keep going because we need the practice. So I'm going to look at AB, BC, CD. CD down here. I got a 2 and a 2. So I'm going to have 2 squared plus 2 squared equals C squared. Right? That's the same thing I had in AB over in my first one. So I know all the work is going to be the same, and I will know the square root of 8 equals C. Right? I had the same numbers in my Pythagorean theorem, so if I did this work all the same, I should get the same answer. And here, my slope is, remember we go from left to right, so it's going up, so I'm going to go up 2, right 2. And then my last side goes from D to A, or A to D, right? This side right here. I'm going to make a triangle. I got 1, 2, 3, 4, 5 units here. 1, 2, 3, 4 units here. So 5 squared plus 4 squared equals C squared. And I can see again, I got the same numbers that I had in BC. Right, so those are congruent sides. That's good. So that means if I worked it out, I'm going to get the same answer. Square root of 41 equals C. And for that one, my slope equals, again, from left to right. If I look over here at my graph, from left to right, it goes down 5, and to the right 4 is positive. So my slope is negative 5 over 4. Okay, so that's a lot of work to find the lengths of all 4 sides and the slope of all 4 sides. And now we have to examine that, analyze that, and figure out what that all means, right? So remember the question was asking me, is this a rectangle? So I can see that I have, right, for AB, so the 2 short sides, AB and CD, the slopes are exactly the same. So that means I have one pair of parallel sides. BC and DA, that's a little too dark there. Right, this guy here and this guy here, those are parallel. So if I kind of come over here, I know I have a parallel side on the short ones. I know I have parallel on the long ones. So I have a parallelogram. Do I have congruent opposite sides? Square root of 8 and square root of 8 for the short sides, those are the same length. Square root of 41 and square root of 41 for the long ones, those are congruent. So far I'm looking pretty good. But now I have to determine, are the slopes, do I have 90-degree angles? Do I have 90-degree angles? So remember, I have to look and see, are these angles right here 90 degrees? So between AB and BC. So between AB and BC, so right here, are these opposite reciprocals? Well, AB, the slope was 2 over 2. So if I flip that, I will still have 2 over 2. And I make it negative, would be negative 2 over 2. That is not what I see right here. Right? Negative 5 over 4 is not the same as negative 2 over 2. So no. And actually, if I keep going and I look at all of these, none of these are going to be opposite reciprocals. So because of that, they're not 90-degree angles. So that means my final answer here, it is not a rectangle. Because there's not 90-degree angles. And I know that because the slopes of the consecutive sides are not opposite reciprocals. If they were, that would tell me they're perpendicular lines that meet at a 90-degree angle. So they're pretty close, right? You can see negative 5 over 4. If that were negative 4 over 4, that would actually be equivalent to -2/2, which would be the opposite reciprocal. So that's a long problem. I think that's probably good for this video. I'm going to make a second video with 2 more examples just for those that need a little extra help. But this is a complete kind of workup here of classifying quadrilaterals, and we'll do a little extra practice in a bonus video.